Hello, welcome to this fourth VANTA GEOCHEM tutorial series. I'm Marcus Lake.
And I'm Todd Houlihan.
In this video, we'll be further discussing the orientation survey, creating a site-specific calibration by adjusting your VANTA's user factors.
In the previous video, we talked about the importance of assessing the instrument's factory calibration on samples of known chemistry.
And we discussed how the results from the VANTA aren't always the same as the laboratory.
Why was that again?
Matrix effects, sample chemistry have got a lot to do with it. As we've seen, the results from your factory calibration are good, but they can always be better by creating a site-specific calibration.
Shall we show how to do that on this phosphate project we're working on?
Yeah, let's have a look at that, Todd.
So here's the phosphorus data as converted from the P2O5 phosphate numbers that are produced from the lab, and here's the VANTA phosphorus results on the same set of samples.
And as I can see there, Todd, it's reading considerably lower.
I think that's right. I think there's a matrix effect going on.
So what are you going to do now with the data, Todd?
Let's create an XY plot, which is something we always have to do if we're to adjust the instrument's factory calibration. Right-click on any data point, add the trend line, display the equation of that trend line on the chart, and display the R squared.
So what do these numbers mean?
The R squared is the coefficient of determination. It's a measure of how well the two data sets correlate. An R squared of 1 is perfect. If it's matrix effects that are causing your XRF to not read accurately, your R squared will almost always be close to 1, and the data should correlate well. If it's less than 0.75, I think there's something else affecting the results.
And what does the equation mean?
The equation is simply a mathematical calculation to convert the X data to the Y data. In this case, the XRF data to the lab.
Okay. You also love a good line graph, don't you, old mate?
Marcus, a line graph is a thing of great beauty. Can I show you why?
I'd love you to, Todd.
The reason I like showing a line graph is because, in my experience, different people view data differently. And this helps us explain the concept of what we're doing here. So the XRF's reading low, but it's consistently low. And to get to move that line up to there, we've got to multiply it by 1.398 and add 2.7% to it. It's that simple.
And this can be done in a spreadsheet or mathematically?
Exactly. It's just maths. We can either do it on board the VANTA or we can do it in a spreadsheet. Should we show that?
Yes, please do, Todd.
Let's do it.
Here's where we adjust the instrument's factory calibration. Swipe down from the top right, touch user factors, and there are the values I entered yesterday. 1.398 being the factor and 27754 being the offset, as per the numbers we just created in the spreadsheet.
And the offset in ppm, not in percent?
Correct.
Okay. And then when we tested the samples yesterday with the new calibration, these are the results that we got. Much closer to the lab value, and they are highlighted here in green, plotted up.
So as I can see there, Todd, you've only used 4 samples. What would happen if the customer had more samples?
More samples, the more robust the calibration. We've sometimes used hundreds of samples, sometimes 20. I know you like the number around 20, don't you?
I do. I usually recommend 20 as a minimum.
Yeah, but you can do it with a minimum of 3, and here we've done 4. The more samples, the more robust the calibration. Shall we test one of these samples with our calibration now?
Yeah, let's have a look how that runs.
All right. Okay, we're going to test sample 16964 with a lab value of phosphorus at 17.98%. With the factory calibration, we measured 10.65%. Now with the new user factors and a quick 15-second test, we're measuring phosphorus at 17.82%.
It looks pretty good, Todd.
Pretty close to the lab value?
Very good.
Good stuff.
There's several other factors to consider when adjusting the factory calibration on board your VANTA analyzer. Here's our list of the most important. Calibration range. When you calibrate the analyzer, you need to calibrate it for all the concentrations you are likely to encounter and as many as evenly spaced points in between.
Sample type. If you're calibrating on lab pulps, then that calibration is set up for that sample type. If you want to test blast hole samples, then set up your calibration on blast hole samples.
Sample matrix. Remember that we're doing this exercise to cater for matrix effects. If you move in between different geological units, you may need separate calibrations.
Sample containers. Your sample containers need to remain consistent throughout your testing process. If you calibrate on samples through plastic bags, then that calibration's set up for that sample container. If you're doing it in cups, try and remain using cups the whole way through.
Testing times. It's very important to remain consistent with your testing times throughout your different projects. But we'll talk about that more in our next video. So that's about all there is for us today. We've covered a lot of ground in relation to creating calibration on your analyzer today, Todd. We'll see you next time.
Yeah, see you next time.
Thank you all for watching.